The ability to travel into space is still a relatively recent event in human history. To get to space, early astronauts traveled in very expensive space capsules, which were only used once before being retired. These systems worked well, but it was realized that a reusable system should be implemented over the single-use capsule system. So in the early 1980s, the world's first and only reusable launch vehicle, the Space Shuttle, came into service. With the shuttle in service, spaceflight became much more accessible and less expensive, while also truly expanding technological and scientific exploration. But in a continued effort to make spaceflight even less expensive and much safer for astronauts, NASA researchers have been looking toward the next generation of reusable space launch vehicles. To help develop the next generation of spacecraft, NASA researchers have been developing and testing a lot of new vehicle technologies. Some of these new vehicles are so revolutionary that they may soon change the way we all think of space travel. I spoke with Charlie Cockrell at NASA Langley Research Center to help explain the next generation of space vehicles.
NASA's goal is to make space travel safer, more reliable, and more cost-effective. One of the goals of the Next Generation Launch Technology Program is to provide routine access to the International Space Station, provide a safer way for crew return from the space station, and to also look at other opportunities in space and be able to do that on a routine basis.
Charlie, how are these new spacecraft so different from the space shuttle we're used to seeing?
Our vision is to really move towards spacecraft that look and operate more like conventional aircraft. So we want to do things like have less turnaround time in between missions. They're going to be more reliable to operate, less repairs that will have to take place in between missions. One of the chief differences between the space shuttle and the vehicles that you're going to see in the future is we're looking at more advanced types of propulsion systems. So they're going to look and operate much differently than the shuttle.
So what are some of the technologies you're using to develop these new vehicles?
Well, in addition to the advanced propulsion systems, we are developing a number of different vehicle technologies that are going to be directly applicable to the next generation set of launch vehicles.
One of NASA's major requirements is to develop new technologies and vehicles to transport crews and cargo to and from the International Space Station. Because the space station is relatively close to Earth and needs to be resupplied frequently, the most logical choice is a reusable spacecraft. One idea under consideration is an air-breathing craft rather than a rocket-propelled spacecraft. To break Earth's gravitational field, a craft needs to reach about 17,500 miles per hour. Currently, this is being accomplished through the use of a series of rockets. These rockets not only carry large amounts of fuel, but must also carry liquid oxygen to mix with the fuel for maximum thrust. Although this system is effective, it is very expensive and can be dangerous. The benefit of an air-breathing craft is that it would not need to carry its own oxygen. It would scoop oxygen from the Earth's atmosphere into a special engine called a scramjet. This system would allow the craft to reach the speed required to break the pull of the gravitational field, sending it into space. Because the craft is not carrying its own oxygen, the weight will be reduced by up to 50%. This could reduce spaceflight costs by a factor of 10, bringing current payload costs from about $10,000 per pound to about $1,000 per pound. So is scramjet technology the only concept you're looking at?
No, we're actually studying a wide range of technologies that include different configuration shapes, different numbers of stages in the vehicle, different types of propulsion systems. Most of the longer-term applications do use scramjets, but we're also looking at something that we would call combined cycle propulsion, which would actually take elements of rocket propulsion, scramjets, high-speed turbojet engines, and maybe other advanced propulsion cycles so that we can use the benefits of those at different points in the flight.
So where will this program be in the next 10, 15, 20 years?
I think we're going to be well on our way to developing a next-generation reusable launch vehicle system. Whether or not we will actually have an operational system in the next 10 to 15 years is going to be dependent on what the nation's needs are and how we address that as an overall strategy. But we are developing technologies that can not only be included in a vehicle that would be developed in, say, the next 10 to 15 years, but we're also developing a lot more advanced technologies that would be good for vehicles that are going to be developed in, say, the next 20 to 30 years. And we're doing all of that by utilizing all of the unique capabilities that we have at our NASA field centers across the country.